Hey folks, I'm Mr. Hartzler, and I just put up a video that was kind of full length, 35 minutes. It's a complete lesson for my students in Algebra 2 on trigonometry and specifically related to things like coterminal angles, quadrants, and the unit circle. So I'm going to do a trimmed down version of that. I've already heard some complaints from my students that 35-minute video is a little long. So let's see what we can do to trim that up. I'm going to do some specific examples. I'm doing it on my little whiteboard deal here. So let me share my whiteboard with you and we'll get started. All right, so let me actually clear this. Okay, so let's start off with coordinate grid. And let's say I'm looking at the angle 60 degrees right here related to my x-axis. So for my students, this is problem 1 on 7.2. So 60 degrees is actually a negative 60 because I start at my x-axis and I go down clockwise. So let's find the positive version of that angle. So it starts here and goes all the way around. So 300 degrees is going to be the other version of this, right? Almost all the way around. I'm 60 degrees short. So I'm 60 degrees short of 360. That's 300. If I go around one full loop, then this green chunk, that's going to be 300 degrees plus a full loop is 360. So that's 660 degrees. I could add 360 to that again. Oh, 360, that's what I'm adding to it again. And then that's 0, 2, and 10. Okay, so I think that's 1020 degrees. I really hope. If not, leave a comment below that my math's wrong or deal with it. You can figure it out from there. Okay, then I have the negative versions of all these angles, right? So I have a negative 60 here. Another spot that's coterminal or ends in the same spot is a negative full circle, which is 360, plus another 60 degrees. So a negative 360, and then I'm going still another negative 60 degrees, right? So negative one full loop, and then negative another 60 degrees. That gets me 420, but again, it's negative. And then I could subtract 360 from it, so subtract 360 again, and that's going to be a negative 780, I believe. And then, of course, the trend keeps going. Okay, awesome. So that is some coterminal angles and finding a couple of them. So let me save this for you and I will delete this drawing. Let's do another one. So this would be the question, sketch the angle in standard position. Standard position if the angle is 210 degrees. All right, so here's my axis. I'm always going to start off with this little grid. So again, it's 180 all the way to here. What's the difference between 210 and 180? 30 degrees. So I'm all the way over to here. And this reference angle for me is going to be written in blue, and it is a 30-degree reference angle. Okay, so again, if 210 is my main goal, I need to go past 180. Okay, but not to 270, right? So I go past 180, how many degrees? 30 degrees makes the difference. So 180 plus this 30 gets me the 210. Okay, so this again is just sketching an angle in standard position. Let's do one where it's a little more challenging, right? So what if I told you that it was a 10-degree angle, but I'm in quadrant 2? Ooh, getting tricky, right? So first, what are my quadrants? So this is quadrant 1. Here's 2, 3. Oh, that's not 3. 3 and 4. Okay, so the 1 before the V means 1 less than V, and V is 5. So 1 less than 5 is 4. Okay. Anyway, so this now means I'm in quadrant 2. So I know I'm over here somewhere. So let me draw a fresh grid. I'm over here somewhere. It's 10 degrees, and that's in reference to my x-axis. So this is 10 degrees. So what is my big angle here? If the little chunk is 10, well, all the way over to this line, right? It's 180. 10 short of that is 170 degrees. Okay, that's all this is. I do want to do another example with this. So this is 10 degrees in quadrant 2. Let us now do 35 degrees in I'm just going to write Q, in quadrant 4. Draw my axis again. So quadrant 4 is down over here. And I'm going to just draw myself a little line. 35 degrees. This is going to almost always be in reference to my x-axis. Unless it specifies otherwise, it is going to be referencing to my x-axis. So 35 degrees in this quadrant. So that means starting here and going positively, well, the whole thing would be 360, and I'm short of that 35 degrees. So 360, I'm short 35. That's a 5 from 10. And then what's 350 minus 30? That's 320. So 325 is my blue angle here. Awesome. So now we've labeled 2 angles in standard position when we're just given a reference angle and their quadrant. All right, hopefully that was helpful. And let's keep moving here. Let's clear this up. And now let's do some conversion. So a lot of my students have trouble with conversions from meters to inches, or inches or feet to decimal inches, or feet and inches to decimal feet, all kinds of stuff. So let's start off with 3 pi over 2. This is in radians. I know that because it either tells me it's in radians or there's no unit at all. So radians don't actually require a unit. So I'm going to convert this into degrees. So I need to multiply by a ratio. And we talked in a couple of my other videos that 360 degrees equals 2 pi radians, which I can simplify to 180 degrees equals pi radians. So I want degrees to be what I end with. So I want degrees, where's my cursor? There it is. Degrees to be on top here, and I want radians to be on bottom. So that means I put the 180 on top and the pi on bottom. Fortunately for us, we have a lot of stuff that cancels, right? Pi cancels with pi. Sweet. So now I have 3 times 180 over 2. I should obviously simplify this. So there's a couple of ways I could do it. I could try and simplify the 3 and the 2. Doesn't work. I can multiply 3 and 180. But that's kind of a big number. Or I could divide the 180 by 2. I could do that because all of these things are happening and it doesn't matter necessarily the order. So I'm going to simplify the 180 and the 2 first. Let me change my color up again, just so to help you guys track along. So I'm going to simplify the 180 and the 2 here. So I still have the 3, and now multiply by 180 divided by 2 is 90. So 90 times 3 is 270, and I'm in degrees. Awesome, right? It's not too bad. I don't think this is too terrible at all. Hopefully you guys can figure that out. So I'm going to clear this again, and let's go the other direction. So let's say I'm starting off with 140 degrees. I need to multiply to get into radians. I am going into radians now. So I want the pi radians on top, and I want the 180 degrees on bottom. My degrees cancel. Unfortunately, this one's not going to clean up in quite as cute of a fashion. So I've simplified now. So I have 140 over 180, and this is going to be in radians. Oh, and I need a pi. Forgot my pi. Me forgetting pi. It's crazy. Okay. So now I can do a little bit of simplifying, just kind of quick, right? 14 over 18 with a pi on top. Because those zeros, they can cancel each other out, right? I can divide the top and bottom by 10. Everything's good. Now I have 14 and 18. Okay, well, that simplifies a little bit further, right? We have a 2 in both of those. So I'm going to divide the numerator by 2, and I get 7 pi. Divide the denominator by 2, and I get 9. And then that's as far as I can go. 7 is prime, so I can't break it down anymore. And again, I don't need my units, but I can write them there anyway. Okay. That is all I wanted to really share with you this go around. Let me stop sharing. Okay, so again, I have that long video if you want to see all of the stuff in lots of detail, several examples, and a lot of words, a lot of the nomenclature, a lot of the definitions and things being involved. But for my students, this is a real quick and short video. hopefully short. It doesn't tell me how long this is, but it's a lot shorter than what the other one was. And hopefully this is helpful for you to answer 7.2's assignment. So have a great day, everybody. Stay safe, and like that, or hit that like button if you like the video and if you want to see more like this, and comment below if you prefer these short videos or if you like the long ones. So, and maybe I just need to do a combination of both. So have a great day, everybody. Stay safe, and subscribe.